All right, so again, I'm sorry, I didn't print this because it's too many pages. So you'll have to, keep this open in another window here. We're going to start with question 2. All right, so this is a parametric question. We have x of t equals t cubed minus 3t squared, and we have y of t equals 12t minus 3t squared. So we want to know when the particle is at rest. That's when velocity is 0. So we're going to do the velocity for both of these. So we have to get the derivatives of both of them and set them both equal to 0. So I'm going to find this derivative, which is 3t squared minus 6t. And then this derivative, which is 12 minus 6t. And we're going to set both of those equal to 0. So this one, I'm going to factor out a 3t. And that'll leave me with t minus 2. And so I get time 0 and time 2. We'll come back to that with, which one it's going to be. Over here, if we set this equal to 0, I'm going to subtract the 12. And so we get time 2. So it's going to have to be time 2. That's when both of these are equal to 0. So I'm going to kind of get rid of that one. Now the answer choices don't have time though. They're x, y points. So you're going to have to take this t equals 2 and plug it back in for both of these to get an x, y point. So if you plug 2 back in here, that's going to be 8 minus 2 squared is 4 times 3 is 12. So that would be negative 4. And if you plug in 2 here, you're going to get 24 minus 12, which will be 12. So negative 4 comma 12 is our answer there. So that one is A. All right, the next one you guys had typed in was 4. And just be patient with me because I do have to jump back and forth between the windows as well here. All right, so number 4, we have the graph y equals ln of x, and they give us the interval from 1 to 2. And this is saying which of the following is the length of the curve. Okay, so that's the arc length. So let me write the formula up here for us. It's integral from a to b, and then a gigantic square root, and then it's 1 plus the derivative squared, and then dx, which is just like one more thing you have to memorize, but that's what it is. And you can use the choices to help you. They all sort of look like that. So it's going to be integral from 1 to 2, big square root, and then 1 plus, 1. So I'm trying to hurry so I can do as many of these as we can, plus the derivative squared. And so the derivative of ln is 1 over x. So, so that is our answer. We're just picking which one looks like that. And I think they wrote this, if you do 1 squared, you get 1, x squared is x squared. So I think they wrote it as 1 plus 1 over x squared, and yeah, they did. So that one is A. All right, let me see what you guys had next in here. Someone said 5 and then 9. So that's what I am going to do next. So we're going to go down to number 5. All right, so we're given f of x equals sum from 0 to infinity, negative x over 4 to the nth. And we want to find f of 3. So we're going to plug 3 in for x. This is negative 3/4 to the n. I'm going to put 1 times that. That just sort of helps me to notice that this is geometric. A is 1. And r is negative 3/4. And when you have something that's geometric, your sum is a over 1 minus r. So that is the formula that we are going to plug into. And so our sum is going to be 1 over 1 minus negative 3/4. So plus 3/4. So that's going to be 1 over 7/4. Which will be 4/7. So I just plugged in 3, it's geometric. And so I used the formula for a geometric sum. So let me go back over. So 4/7, so that one is C. All right, so next one we're going to look at is 9. Okay, this one's going to take a little bit of time because there's all these choices here. It says, which of the following converge? All right, so we're going to have to test each of these and see which one converges. I'm actually going to do this one last because it's going to be the longest. So let's look at Roman numeral 2. If we do limit as n goes to infinity for this, I realize the denominator is n to the 100th, but a factorial is going to grow faster than anything. So this is going to go to infinity. And so that diverges by the nth term test. And obviously, when you're taking the AP exam, you don't have to write this out because it's multiple choice. I'm just writing it here because we're going over this together, and I'm just trying to explain to you like why that's the answer. So we don't want Roman numeral 2. And so if you even notice that, you can like narrow down your choices. If you're like, oh, this problem's overwhelming, if you at least get that one, then you can narrow down the choices. All right, so Roman numeral 2. I have n to the first in the numerator, and then I'm going to have n to the third in the denominator if you multiply that all out. So if you have n over n to the third, one of the n's is going to cancel, and we're going to compare this to 1 over n squared. And so p is 2, and so that is going to converge because 2 is bigger than 1. And again, you don't have to go through, is it a direct comparison or is it a limit comparison and proving all of that because it's multiple choice. So you just have to pick the right answer. So we got that we don't want 2, but we do want 3. So actually, can you pick the choice based on that? I hadn't looked back through that. We don't want 2, but we do want 3. No, we have to still do the last one. Oh, bummer. But you can narrow it down. Oh, because it might be D. Yeah, I see what you're saying there. Okay, but my point is you could narrow it down. The reason that this Roman numeral 1 is going to take a while is because nothing really works for it. It's not geometric. It's not a P series. There's really nothing we can compare it to. We're going to have to do a ratio test. So it is a limit as n goes to infinity of this gigantic absolute value here, and we're going to plug in n plus 1. So we have 8 to the n plus 1 over n plus 1 factorial over the series itself. And so limit n goes to infinity. This denominator is going to reciprocate. So we'll have 8 to the n plus 1 times n factorial in the numerator. And then everything else is going to go in the denominator. And then you're looking for stuff that's going to cancel out. So all the 8s are going to cancel out except for 1. And then this is n plus 1 times n minus 1, you know, all the way down forever and ever. So that's all going to cancel except for n plus 1. And then if you do the limit as n goes to infinity, this denominator is going to get astronomically large. And so this is going to go to 0. And the ratio test says as long as this is smaller than 1, it's going to converge. Bigger than 1, it's going to diverge. If it equals 1, then you don't make a conclusion. But we got that this is smaller than 1, so this is going to converge. So we want Roman numeral 1 and 3, which is D. All right, I'm going to keep going until 240 on this section of questions. So anything else from numbers 1 through 18 that you want to look at? All right, number 7, everybody. And don't be shy. I want to use all the time that we have here because we only got 2 days to do AP review. So I want to do as much as we can. All right, so number 7, we're given, oh, they threw an arc sine in here. Arc sine equals ln of y. It says find dy dx. So again, one more thing that you have to memorize, your derivative of arc sine is 1 over square root of 1 minus x squared, which I realize is like not something you just walk around in your daily life knowing, but make yourself some flashcards before you go into the AP exam in case they throw one of those inverse trig derivatives at you. All right, derivative ln, that's 1 over y in this case, and then we have to multiply on dy dx. And then the only step you have to do to get dy dx by itself is to multiply that y to the other side. So it's going to be y over that square root of 1 minus x squared. And so that one is A. All right, 14. Let me see, I'm getting close to the bottom of the paper. I wonder if I'm going to have enough room for this one here. Let's see what 14 is asking us for. Sorry, I'm just trying to scroll down to it. All right, it says let k be a positive constant. Which of the following is a logistic differential equation? All right, again, one more thing that you've got to memorize. Did anybody look at the recap that I posted? Like, you know how I did one for the midterm and then I did one for the second half of the year? It's all on there. So this is k times y, L minus y. And remember, L is that carrying capacity. So like, remember we did like population of deer and the environment can only support a certain number of deer. That's where their population is going to level off. Anyway, it's going to follow this format. So we just need to pick the choice that looks like that. And it looks like they put in 1 for this carrying capacity. So the one that follows that, ky, and then they have 1 minus y, that's choice E. All right, I've got 5 more minutes that I was planning on doing on this section. So anything else on 1 through 18? All right, number 11. All right, so they give this really weird function. I'm going to be honest, what I would do with this was like me taking the AP exam. I would just graph this. And I realize that you don't have a calculator, but you can just plug in numbers and find points to plot. And I would just draw a quick sketch and just look at it. And I know this is going to be shifted over 2. So I'm going to start at 2. If you plug in 2, and this is really weird, it's a square root of an absolute value. If you plug in 2, you're going to get 0. So that's going to go there. And then I'm just going to try some values, on either side here. So let's try 1. 1 minus 2 would be -1, but you're going to absolute value that, so that's +1. And then square root of 1 is 1. And then the same thing is going to happen on the other side. This is going to be, symmetric. All right, so let's try another number. 1 and 3 gave us the same result. If we try 4, though, we're going to get 4 minus 2 is 2. Square root of 2 is not real nice. So let me go out a little further. I want to pick a number that's going to be, pleasant here. So let me go out to 6. So 6 minus 2 would be 4. Absolute value, that would be 4. And then square root of 4 would be 2. So I'm going to get 6, 2. And then the same thing's going to happen over here at -2. So -2, 2. So what you end up with is something like this. And I'm going to be honest, if I was the one taking the AP exam, I would have just drawn a quick sketch of that. You can draw any graph, just plug in points and see what you get. And then I think let me look back at it. I have to keep toggling between the screens here. All the choices were like, it's continuous, it's differentiable. So this function is continuous, but not differentiable. at 2. So let me see which choice says that there. A, f is continuous but not differentiable at 2. So continuous, there's not like a hole or a gap there, but we have the sharp edge, so it's not differentiable. So I would just draw the graph. All right, and I have time for one more from this section. So do you guys want to pick one more from 1 through 18? All right, 13. All right, radius of convergence. Okay, so this one's going to be another ratio test. Let me write out the problem here. We've got sum 0 to infinity, x minus 4 to the 2n over 3 to the n. So radius of convergence is your ratio test. This is going to converge where whatever we get out of the ratio test is smaller than 1. All right, so limit as n goes to infinity, gigantic square root. Let me come back to the screen so I can see what I'm writing here. All right, and we're going to plug in n plus 1. So this would be x minus 4 to the power. Now we would have 2 times n plus 1. So that would be 2n plus 2, if you distribute the 2 through there, over 3 to the power n plus 1. And then that is over the series itself. So you plug in n plus 1, and then it goes over, what you've got. So then this denominator is going to reciprocate. So this part, this 3 to the n, is going to come up to the numerator. Everything else is going to be in the denominator. All right, so once again, limit n goes to infinity. Now we're looking for stuff that is going to cancel out. Or you could think of this as subtracting the exponents. When you divide, you're subtracting the exponents. So the 2 n's are going to cancel. You're just going to have x minus 4 squared. And then all the 3's are going to cancel except for 1. So just 3. Now the limit is kind of, we got rid of all the n's. All the n's canceled out. So limit as n goes to infinity. Well, it's just going to be this. You can sort of ignore this if you want. And it's going to converge where that's smaller than 1. So we're going to multiply over the 3. We're going to have x minus 4 squared less than 3. And then we're going to square root. So this is centered at 4. And your radius of convergence is square root of 3. So like if you were trying to find your endpoints, well, gosh, it would be really weird. It's centered at 4. And then you would go, square root of 3 in each direction. But square root of 3 is the answer to that one. So let me see what that was. So that is C. All right, so it's 2:40 now. My clock says 2:41, close enough. Let me stop this recording here.